everyone, this is Mallikarjun, Assistant Professor, Department of AAA. So today we are going to discuss about our next topic, that is time response analysis. So there are two types of time response analysis. One is transient state and steady state. So we are going to discuss about each and every response in a detailed manner with respect to the expressions and also the graph of each response here. Right? Coming to our first topic, that is time response. So before going to discuss about time response, we will see the definition of it and how the types of time response have been divided. So if the output of an electrical circuit varies with respect to the value of input of a time, then it is called as a time response. Then it is called as a time response. If the input varies with respect to time, if the input varies with respect to time, the particular graph which is obtained for us is considered as a time response. So I can show you a graph with respect to that, a normal graph. So if this is the time, I am taking the input in the form of a t, and this is nothing but my credentials, it may be voltage or current. So the graph which is obtained between voltage or current with respect to the time can be considered as a time response of a voltage, or else it can also be considered as a time response of a current. Time response of a current. Suppose if you want to calculate the time response for a particular circuit, you need to calculate the two types of responses. The first one is transient response and the second one is considered as a steady state response. The first one is transient response and the second one is considered as a steady state response. So in order to calculate the time response of a circuit, let me consider the time response is considered as CT. In order to calculate the time response of a circuit, we need to calculate the transient response of a circuit, that is TR, and also we need to calculate the steady state response of a circuit, that is SS. So by taking the sum of the transient response and steady state response, we are going to get the total time response of a given circuit. Total time response of a given circuit. It may be a combinational circuit, it may be individual circuit, it may be anything, where it is a combination of both the active elements and also passive elements. In order to get the total time response of a circuit, you need to calculate the transient response of that particular circuit, as well as you need to calculate the steady state response of that particular circuit. By taking the sum of those two things, you are going to get the time response of the circuit. So you can see the expressions which is written here. C of t equal to, where C of t is considered as a time response, CTR is considered as a transient response, and CSS is considered as a steady state response. Coming to the next, this is the graph. This is a graph where C of t is nothing but our input, which is varying with respect to the value of a time. Now you can see the different states that are involved in this particular graph. Up to a particular point of time, it is considered as a transient state. And after completing that particular point, it is considered as a steady state. So by seeing this, we can clearly give the definition for a transient state and also a steady state. So the time taken to reach the steady state point can be considered as a transient response. So this is the time taken by this particular response in order to reach this particular steady state point. This total state is considered as a transient state, and the response that is obtained in this particular state can be considered as a transient state response. After crossing that particular point, you can see the value of the graph is completely a standard one. That is, whatever it may be the change in the value of a time, the graph will never change, and this state is considered as a steady state, and the response obtained in this particular state is considered as a steady state response. You can see the graph clearly. It gives you an idea about how the graph for the transient response will be and how the graph for the steady state response will be. So how can you define by seeing this particular graph? The time taken to reach the steady state can be considered as a transient state, and the response obtained in that particular state is considered as a transient state response. And after crossing that particular state, the response is considered as a steady state response. Coming to the next slide. Now I will define you what is the transient response. So after applying input to any type of control system, the output will take certain time to reach a steady state value. So we have seen the graph earlier. Suppose this is nothing but my output. I am taking the time as an input here. So the time, the output will not raise directly with respect to this. It will take certain time to reach the steady state value. the time taken to reach this particular steady state value is considered as a transient time, and that state is considered as a transient state, and the response obtained in that particular transient state is considered as a transient response. So what is the reason why we are not getting the steady state response directly? Because of due to the presence of the passive elements called inductor and capacitor in the circuit, or else there may be a chance of having a switch in a circuit. For example, let me have a circuit like this, which it is a series RL circuit which consists of a switch, and I am giving some amount of supply to this particular circuit. So due to the presence of a switch and also a passive element or energy storage element called inductor, there will be a chance of having a transient response of this particular circuit in a clear way. So the transient response will occur in any circuit due to the presence of a energy storage elements like inductor or capacitor, or else due to the presence of a switching action. Switching action is nothing but what? Opening the switch and also closing the switch. So the transient response in any circuit will occur due to three things. One is due to the presence of an inductor, the other one is due to the presence of a capacitor, and the other one is due to the switching action, which switching action include opening the switch or closing the switch. Opening the switch or closing the switch. So therefore, the response of the electrical circuit during that particular transient state can be considered as what? Transient response. So the key points what you want to keep in your mind here is the transient response is mainly due to the presence of a switch, or due to the presence of a energy storage elements called inductor and capacitor, and the response obtained in that particular state can be considered as what? Transient response. Transient response. Coming to the next slide. Now we will discuss about how the inductor will behave during that particular transient state. Now let me assume that the switching action is taking place at time equal to 0. At certain time t equal to 0. So we have certain properties of an inductor. The first property is stores the energy in the form of a magnetic field. It opposes the sudden changes in the value of a current in the second property. So as for the property, as I am changing a switching action suddenly here, suppose let me take a circuit like this, and it is a purely inductive circuit. Previously the current flowing in the circuit was how much? 0. And at t equal to 0, I am trying to close the switch. At t equal to 0, I am trying to close the switch. So after closing the switch, in general, according to our knowledge, there's some amount of current should start flow through that particular inductor which is connected in the circuit. But as for the property of an inductor, it opposes the sudden changes in the value of a current. So due to that, previously the current was 0 when the switch is what? When the switch is open. When the switch is open. Now what I am doing at time t equal to 0, I have closed my switch. Now the circuit is completely a closed path. Then it need to have certain amount of current in it. But due to the property or special property of an inductor, that is, it opposes the sudden changes in the value of a current. It opposes the sudden changes in the value of current. So before closing the switch, that is when the switch is open, the value of current is 0. And when I have closed the switch, the current will be 0 up to certain period of time because of the property of an inductor. Because of the property of an inductor. That is, the final conclusion is how the inductor will behave here. The switch, the current flowing in the inductor before closing the switch, where it is indicated by 0 minus, and the current flowing in the switch after closing the switch, that is 0 plus, is equal in an inductor due to its special property. What is that property? It opposes the sudden changes in the value of a current. It opposes the sudden changes in the value of a current. Coming to the next slide, capacitor behavior under transient state. So as that of an inductor, similar to that of an inductor, capacitor also has a certain special property where it opposes the sudden changes in the value of a voltage. Suppose I am taking a switch like this, and I am taking a capacitor circuit where I am applying some amount of voltage to it. So before closing the switch, the voltage across this particular element will be 0. Why? Because as the switch has not closed, when the switch is not closed, the current will be equal to 0. If current is equal to 0, voltage connected in that particular circuit will also be equal to 0. So initially, the voltage across the capacitor V of C minus is equal to 0. Now the switching action is going to take place at t equal to 0. The switch is closed. That is VC of 0 plus should be defined. VC of 0 plus should be defined. But there is a VC of 0 plus. When I am closing the switch, there should be some amount of voltage drop across the capacitor that is connected in the circuit. But it is not possible in this particular case because of the special property of a capacitor. Because of the special property of a capacitor. What is that property? It opposes the sudden changes in the value of a voltage. So before closing the switch, the value of voltage that is present across the capacitor was 0. After closing the switch, up to certain period of time, the value of voltage will be equal to 0 due to its special property. So this is the behavior of a capacitor under the transient state. VC of 0 minus is indicated as voltage across the capacitor just before closing the switch. VC of 0 plus is indicated as voltage across the capacitor just after closing the switch. Coming to the next topic, steady state response. So we have seen the graph earlier. Up to certain period of time, the graph has a transient state, and after reaching this particular point, the graph completely has a steady state. And the response that is obtained in this particular steady state is considered as what? Steady state response. So it is clearly defined as the part of the time response that remains even after the transient response has 0 value. Even the transient response has 0 value, whatever it may be the value of a time. The time may be infinity or whatever it may be, that type of response is considered as a steady state response. And in this state, there will be no presence of any transient response elements. Now we will study the behavior of the inductor, and also we will study the behavior of a capacitor for a steady state response. First, we will study about the behavior of an inductor under the steady state condition. If an independent source is connected to an electrical circuit or network having one or more inductors for a long period of time. Suppose I am taking an inductor like this, a switching action and an inductor, and let me say some amount of voltage is given to this particular circuit. So before closing the switch, the current was 0, and after closing the switch up to certain period, the current is 0 in this particular circuit in case of an inductor because of its property. But if I am connecting that particular inductor for a long period of time, after closing the switch, that particular network or circuit will be completely in a steady state. That is, it has crossed a transient state and it has completely moved to the steady state whenever the inductor is connected to a particular circuit for a long period of time. So when you are connecting an element called inductor for a long period of time in a particular circuit, that circuit is said to be in steady state condition. And the energy stored in the inductor of that particular circuit can be maximum, and it is maintained as a constant. So the general formula to indicate the energy that is present in case of an inductor is given as W equal to half Li square. So as I am connecting an inductor for a long period of time, the circuit has reached to the steady state, and under steady state condition, the energy stored in case of an inductor, that is half Li square, is maintained as a constant. So if the value of energy is constant, whatever the value of current, it is maintained as a constant. From the above expression. So the inductor will generally act as what? It acts as a constant current source whenever it is present in a steady state. Inductor will act as a constant current source in case of a steady state. So if I want to calculate the voltage across the inductor, the formula to calculate the value of voltage across inductor is L into dA by dt. The current obtained previously was constant. So the differentiation of constant is considered as what? 0. differentiation of constant is considered as what? 0. So, under steady state condition, inductor will act as a constant current source element. Inductor will act as a constant current source element, and the voltage across the inductor is considered as how much? 0. If the voltage across the inductor is 0, you need to replace the inductor on that particular element as a short circuit. Voltage 0 in general indicated as short circuit, and current 0 in general indicated as what? Open circuit. So the voltage across the inductor, as it is a constant current source in a steady state condition, the voltage across the inductor is obtained as 0. If voltage is 0, it should be indicated by a short circuit. That is, inductor in my circuit should be replaced by a short circuited dead element. Short circuited dead element. Similarly, we will discuss about the capacitor behavior under a steady state condition. Capacitor behavior under a steady state condition. Similarly, as that of an inductor, I will take a capacitor with respect to the value of switch, and I will use some amount of voltage to that particular circuit. So before closing the switch, the current flowing or voltage across the capacitor was 0. After closing the switch up to certain period, the voltage across the capacitor is considered as 0 due to its property. But if I am closing the switch and I am keeping the capacitor for a long period of a time in that particular circuit, now this circuit will behave as a steady state circuit. Now this behaves as a steady state circuit. Again, under steady state circuit, the energy stored in case of a capacitor, which is considered as half CV square, is maintained as constant. If energy is maintained as constant, the voltage present across that particular element is also maintained as constant. That is, voltage across the capacitor is also maintained as what? Constant. And you know the expression for the current. As voltage is constant, and how the capacitor will behave under a steady state condition? Constant voltage source. Inductor will behave as constant current source, and capacitor will behave as constant voltage source under what condition? Under steady state condition. Under steady state condition. So when voltage is maintained as a constant in this particular circuit, the expression, general expression for current in case of a capacitor is given as C into dV by dt. As voltage is constant, differentiation of this particular constant factor can be given as what? 0. So if the current is 0, in general it is indicated by a open circuit state. Open circuit state. So under steady state condition, inductor will behave as a constant current source, and it should be replaced by a short circuited element in the circuit. Under steady state condition, capacitor will behave as a constant voltage source, and it should be replaced by a open circuit under a steady state condition. So if I want to calculate the total time response of a circuit individually, you need to calculate the value of a transient response, and also you need to calculate the value of a steady state response. In order to study the behavior of an inductor and a capacitor in case of a transient response, and inductor and capacitor in case of a transient response, we have gone through it. And under steady state response, inductor will behave as a short circuit, capacitor will behave as a open circuit. And in case of a transient response, current flowing initially will be equal to after closing the switch in case of an inductor, and voltage flowing through the capacitor. Voltage flowing through the capacitor before closing the switch and also after closing the switch will be equal. So if you calculate the transient response and also the value of the resisted response by taking the sum of these two things, we are going to calculate the total time response of the given circuit. Either it may be a resistive circuit or inductor circuit or capacitor circuit combinations. It may be a combination of series circuits, or else it may be a combination of a parallel circuit. So we will meet in the next class.
Like, share and subscribe. Hit the bell icon for more updates.